Alright, so welcome to this lesson once more. We are going to be talking about thermal expansion, and specifically in this lesson we'll look at what? Linear expansion there. Okay, so these are the objectives there. We're saying define thermal expansion, and then define linear expansion, and then we are going to solve exam sample problems. Okay, and then at the end I'm going to give you guys an assignment. Okay, so it's just one question for you guys to try out. Okay, so last time we had a class, I gave you questions, you guys, but only one person submitted. So I don't know if you are taking these lessons seriously or you are not. Okay, if you are not, I encourage you to start practicing. Okay, so let's define what thermal expansion is. Okay, so by definition we'll say thermal expansion is the increase, okay, in the dimension of a body due to increase in what? Temperature. Okay, so from the word itself, thermal expansion, so meaning the expansion that is caused by what? By heat. So some sort of the heat will cause this expansion. No wonder we are calling it as the thermal expansion. Okay, so this thermal expansion, it can happen in terms of length. Okay, it can also happen in terms of volume, and it can also happen in terms of what? The area. Okay, so when we talk about the length there, we are going to be talking about the increase in length of what? Solids. Then when we talk about the expansion in terms of volume, okay, the expansion in terms of volume, we are going to call that as volume expansion. Okay, so when we are talking about volume expansion, okay, it will be the expansion of that certain material in terms of its volume due to the change in temperature, or due to the increase in what? Temperature. So this volume expansion, it can occur even for liquids. Okay, but for the linear one, it's only what? Solid. So the volume can expand, and we can get the volume of a liquid there. Okay, and then when we talk about the area here, it's just the area that is expanding due to the increase of what? Of temperature. Okay, so we know that when the area increases, it means the length has increased and also the width has increased. Okay, so when you talk about the area, it will be two things that are increasing: the length and also the what? The width. Okay, so in this video we are just going to concentrate on the linear expansion, where the length increases of solids there. Okay, so what is linear expansion and what is its formula? Okay, so this is just the increase in length of a solid, okay, due to temperature changes. Okay, so you can see here I have an illustration there that I've written out. Okay, so I have this rod here that has the length L. Okay, so after exposing this rod, okay, to heat, it expands like that. Okay, so you can see the part that has expanded here, it's this part here. Okay, this part here has what? Expanded. Maybe yellow is not good. Okay, so this part here has expanded like that. Okay, so it had this length L, and then now we have plus C, okay, another length there. Okay, that has caused this change in temperature there. So that is what linear expansion is. The solid is just expanding due to exposure to a higher temperature. Okay, so when we are finding this linear expansion, we use this formula here that I've written out on the right there. So we say the change in length is equals to alpha multiplied by Li multiplied by the change in temperature. Okay, so this change in length, okay, this change in length is just the final length minus the what? The initial length. So the length from this guy all the way up to where it is ending now, that after it has expanded, that will be your final length, and then your initial length is just this original length that this rod had before the expansion took place. Okay, so LF will represent the original length, LI will represent, LF will represent the final length, and then LI will represent the original length. Okay, and then this alpha here, okay, that alpha there represents what we call as the linear expansion coefficient. Okay, so the linear expansion coefficient you are always given in the question. Okay, so you'll be given that linear expansion coefficient in the question. Okay, and then LI, we know what it means, and then this triangle and the temperature here simply means change in temperature. Okay, so how are we finding the change in temperature? We are subtracting the final temperature minus the initial temperature. Okay, so this is what I was trying to explain here. And then an important thing to note is that, okay, the units for this linear expansion coefficient, okay, are just degrees Celsius, and then you put them to the power minus 1, or you can say kelvins to the power minus 1. Okay, I think I didn't type this properly here. Okay, so degrees Celsius to the power minus 1 or kelvins to the power minus 1, or we know that if this is raised to the negative power, it's the same as 1 over this degrees Celsius, like that. So these are the units for the linear expansion coefficient. Okay, so for us to find the linear expansion of a certain solid, okay, we just need its original length, okay, its final, and then the change in temperature and the linear what coefficient, so we can be able to find. Okay, so we're going to be using this same formula here. So now let's look at some questions. Okay, let's look at some questions where we are finding this linear expansion. Okay, so the first question is what we are seeing on our board there. So we are going to solve that question. Okay, we are going to solve that question. So they are saying a solid rod is made of a substance that has a linear thermal expansion. Okay, so this is the coefficient of expansion. Okay, 2.5 times 10 to the power minus 6 per degree Celsius. Okay, and then they are saying the rod increases in length by 0.15 millimeters, okay, when its temperature increases by 80 degrees Celsius. Okay, so find the length of the rod before and after. Okay, so what is the length what is the length of this rod before and after? Okay, so what are we going to do there? Okay, before and after the temperature increase, there are some missing words here. Okay, let me make them sure. All right. Okay, so what is the temperature? Temperature, right? What is the length? Okay, what is the length of the rod before and after the temperature what increase? Okay, so we have been given first of all here the expansion coefficient. So the expansion coefficient is 2.5 multiplied by 10 to the power minus 6, okay, per degrees Celsius, like that. Okay, what else have we been given? Okay, so when we read from the question, when its temperature increases by 80 degrees Celsius there, so meaning the change in temperature, okay, it's just what, 80 degrees Celsius. This is the change in temperature. Okay, and then here they're saying the rod increases in length by 0.15 millimeters there. Okay, so increases in length by this, it means what? Okay, what does that mean? Does it mean this is the change in length, or it's just the increase in length? Okay, so this is just the increase in length, it's not the change in length. Okay, so the rod increases in length by that much, so meaning that, okay, if I have my initial length like that, okay, I have my initial length like that, let's say my initial length is x, okay, so this rod has increased by 0.15 there, it means my final length will just be what, x plus 0.15 there. Okay, so now our task here is to find this x, and which is the same as this x. Okay, so we are going to use the formula for linear what expansion. So we know that the change in length is just equals to alpha multiplied by the initial length, and then we are going to multiply by the change in temperature. So the change in temperature, we also have it there. Okay, so let's try to substitute in this length here. Okay, so our first okay, so we are going to say our final length is just x point 0.15. We are finding this change in temperature. We said final minus initial. Okay, and then minus the initial, which is x. Okay, so this is our change in length, and then this is going to be equals to, what is our alpha? Our alpha is 2.5 multiplied by 10 to the power minus 6 multiplied by, what is our initial length? Our initial length will be x multiplied by the temperature. Okay, the change in temperature will just be what? 80 there. Okay, so what is left here is just to do some calculations. Okay, so we see that on the left hand side there, okay, we see that on the left hand side there, what are we going to have? Okay, on the left hand side, this x minus this x, they are going to cancel, so we are going to remain with 0.15 is equals to, and then on the other side we are going to multiply this 2.5 times 10 to the power minus 6 multiplied by this 80 here. So what do you get? So you just get your calculator, and then we try to punch in those values. Okay, so where is my calculator here? So let's say 2.5 multiplied by 80. Okay, when I do that, I get 200, and then multiplied by 10 to the power minus 6, and then multiplied by x. So our goal here is to find this x, which is the original length. Okay, and then once we have the original length, we can just add this 0.15 to find the final length. Okay, so it means our x will just be equals to 0.15 divided by this 200 multiplied by 10 to the power minus 6. Okay, so what are we going to get there as our answer? We just go to our calculator, we divide that one. So we have, okay, we have let me write this on the scientific calculator. So we have 0.15 divided by 200 multiplied by 10 to the power minus 6. Okay, so that is what we have there. So when I divide that, I'm getting my answer to be 750 millimeters, like that. Okay, so this here will be my what? My original length. So I'm going to write original length, which is Li, will just be equals to what? 70 and then millimeters, like that. Okay, so what else am I going to find here? We're going to find the length of this rod after the temperature increase. So the L final there will just be equals to the initial plus the increase. Okay, so we know that the L final there will just be 750 plus, okay, 750 plus the 0.15 there. So we are going to have what? 750.15 millimeters. Okay, so this is the length after the temperature increase. This is the length before the temperature increase. Okay, so any questions there on how we are finding that question? Any questions? Okay, so if there are no questions, let's solve the other question now. So the other question, it's this one here that you can see on your board. Okay, So we are just going to use the same formula to come up with the answer here. So let's read the question. So the question is, by how much will a steel rod of 5.5 meter long expand when heated from 35 degrees Celsius to 80 degrees Celsius? Okay, and then they're saying the coefficient of expansion of this steel is just 3 times 10 to the power minus 5 per degree Celsius. Okay, so what are we going to do here? Okay, the first thing is to find the change in temperature. Okay, so the final temperature will be this 80 here, the initial will be this 35. So it will be 80 minus what? 35. So our change in temperature, okay, our change in temperature will just be 80 minus 35, which will give us 45 degrees Celsius. Okay, so this is our change in temperature. And then our initial length, okay, our initial length will be what? 5.5 meters. Our final length, we do not know it, so we'll just put x. Okay, we don't know the final temperature there. Okay, and then the coefficient, okay, we know. So the coefficient will be given as 3 multiplied by 10 to the power minus 5 degrees Celsius. Okay, and then to the power minus 1, like that. Okay, so this is all what we need in order to find the how much of what they are asking here. By how much will a steel of this long expand? Okay, so we're just finding the change in length. That's the how much they are asking about. Okay, so the change in length, we know that it's equals to the coefficient of expansion multiplied by the initial length. Okay, and then we multiply this by the change in what? Temperature. So this is going to be equals to, the change in length will be equals to the coefficient of expansion will be 3 multiplied by 10 to the power minus 5. Okay, and then okay, so this is our coefficient of expansion, and then we are multiplying this with, okay, we are multiplying this with the initial length. So the initial length will be 5.5. okay, and then we are multiplying that by the change in temperature. Okay, so the change in temperature, we found it to be 45. Okay, so this is what we have here. So to find the answer, we are just going to say this is equals to, and then you simply multiply those numbers on your calculator. So we have 5.5 multiplied by 45, and then multiplied by 3 multiplied by 10 to the power minus 5. Okay, so my scientific calculator is giving me this 0.0 0.07425. Okay, so these will be in meters like that. So this here is my change in what? Temperature. Okay, so you can say now that that 5.5 steel rod, okay, will increase by 0.0074 meters. Okay, and then the other question can be find the final length. Okay, so the final length, we're just going to say this is equals to the initial, which is 5.5 plus 0.007425. okay, so this will give us 5.507.425 meters as our final length. Okay, so you can see that the calculations are not hard, as long as you understand the question and then you correctly apply this formula here. Okay, so any questions there, guys? Any questions? Okay, no questions. Okay, so it means we are done for this class. I just wanted to talk about the linear expansion. Okay, and then I have a question here for you. So you can screenshot this and then you try it out. Okay, so it's just one question. Make sure you try it out. You see if you've understood the concept. Okay. All right. So if there are no any other questions, then that's the end of our class. So have a blessed night, guys. Oh, someone has a question? Yes, Peterson. Do you have a question?
Yes, I have a question.
Okay.
When are we supposed to hand in this assignment if it's to be handed in?
You can hand it in anytime today or tomorrow.
Okay.
All right.